This is the Perma-Proto ATmega328P with PCB. However, because the PCB is still in shipping, I'll be using a Perma-Proto instead, but to more easily explain the circuit, I'll be using a breadboard. Before I show the breadboard, this is what the PCB will look like when it arrives, with the top view, the bottom view, and you can see the wires and the pinouts in this one. The circuit has two buttons and a slide switch, having a 330 ohm resistor connecting to power and a 1K ohm resistor acting as a pull-down resistor to ground. The outputs are also connected to the analog pins so their state can be read in the code. And here are the shift registers connecting to the matrix. When the left button is pressed, the LED moves to the left. When the right one's pressed, it moves to the right. And if both are pressed at the same time, it either goes up or down depending on the stat of the switch. This is the Perma-Proto ATmega with PCB code. It starts off by defining the shift register pins as well as the starting LED value, which is the display value. In the setup, it defines the shift register outputs and the input pins for the button and switches. In the loop, it starts off by setting the latch pin low and then reading the horizontal value function. The horizontal function reads the button 1, and if it is high, then it multiplies the display value, which shifts it to the left 1, and if the button 2 is high, it divides it by 2 and shifts it to the right 1. Then the code sets the column as the display value and then reads the vertical value. The vertical value reads all the buttons and switches, and if both buttons are high at the same time, if the switch is high, then it will go up a row, and if the switch is low, it will go down a row. After that, it shifts out both the column and row, and then has the latch pin go high and has a delay.